All right, in this lesson, we're going to look at congruent triangle proofs dealing with angle, side, angle, and angle, angle, side. So the first one we're looking at is angle, side, angle. So once again, congruent triangles have 6 corresponding parts that have to be congruent. So all 3 angles, congruent to all 3 sides, corresponding sides. Now, then the shortcuts here, if we know only certain information, like we looked at side, 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 and side, angle, side. So this one here is angle, side, angle. So if 2 angles and the included side of one triangle are congruent to 2 angles and an included side of another triangle, then the triangles are congruent. So in this case here, for reading this triangle here, we have if angle A is congruent to angle D, and AB, side AB here, is congruent to side DE, and then we also have another angle here surrounding it, so that's going to be the same thing as saying angle B congruent to angle E. So if all this happens, then we can say now that triangle ABC is congruent to triangle DEF based on side angle or angle side angle. Okay, the side has to be in between the 2 angles. Remember, the side is going to touch both angles like it does here. Side AB touches our angle here, and then we have our side DE, which touches angle D and angle E. So remember, included means the side in between the angles. So let's look here at the first proof, okay? So SQ bisects angle RQT and angle RST. So once again, we're going to first start that with our given. So we're going to write down given here. Now we're going to mark what we know, RQS. So RQS is referring to this angle here, and it's congruent to angle TQS. Well, how do we know this is true? That is because of the angle bisector theorem, okay? So what we'll do is we'll say this is the definition of an angle bisector. So definition of angle bisector. Okay, and that's what we know. If you know something's bisected, it's going to cut it in half. You just have to be able to name which parts are cut in half. So that gives us an angle measure here. Now notice here, this next one here, angle RSQ is congruent to TSQ. So RSQ is this angle here, congruent to this angle here. And once again, this is going to be the same reason, definition of angle bisector. Okay, angle measure here. And then we have our last one here. By the reflexive property, this side is congruent to itself. So QS is congruent to QS. So that we know that's reflexive. So we have angle, angle, and a side here. So if you look at our page here, we have an angle measure here, a side, and an angle measure here, angle, side, and angle. The side length is in between the 2 angles, so we can say now that this triangle is congruent. These 2 triangles are congruent by angle, side, and angle. All right, let's take a look at the next one. So now it tells us JK is parallel to LM and JL is parallel to KM. So notice they started putting some of these statements on the same line here. And of course, that reason is going to be given. So it saves a little space here. And so we're going to put here that they're parallel. So we're going to use our little arrows. Okay. Arrow here, arrow here. These are parallel. Now JL is parallel to KM. So we're going to put that symbol here. Put 2 here to show that these 2 go together. Now, remember what parallel lines tell us. It tells us we're probably going to have some of our special angle pairs. So now, angle JKL is congruent to MLK. So, JKL congruent to MLK. These 2 here. And that is going to be by the definition of, well, these are congruent. It would be definition of parallel, but these are alternate interior angles. So we'll put alternate interior angles. Okay. The next one here is JLK congruent to MKL. So JLK is this one here, and MKL is this one here. Once again, because these touch the parallel line and the transversal, these are also a pair of alternate interior angles. So we have an angle measure, and now we have a side of our overlapping triangle, so that's why it's KL congruent to LK, and therefore This again is by the reflexive property. So that gives us our side length here, so we're going to go ahead and mark it here. So we have an angle, side, and angle, congruent to angle, side, and an angle. And so we know this is true by angle, side, angle. All right, let's look at number 3. So number 3, we know that, and then we have no statements, no reasons to give. So let's go ahead and start by writing down what we know. We know that angle BAC congruent to angle DEC. Okay, that's going to be given. Now, let's go ahead and mark it on here. BAC is referring to angle A. I'm not sure why they didn't say angle A here. And DEC is also going to be the other angle. You could call this angle E. So those two are given. That's an angle measure. So now we look at the next one. C is the midpoint of AE given to us. So what does that tell us? Well, if C is the midpoint of AE, that means it cuts it in half. So C is our midpoint, which means that we're going to have a half over here, the same length as the half over here. So we need to be able to, so that's what we write down next. We need to describe that, what we know. So I'm going to say AC is congruent to, since it started with A, and I know A matches up with E, I got to go E to C. So we get that from our congruency statement here. A matches up with E. And once again, how do we know this is true? Well, this is going to be the definition of midpoint. All right, so now we have a side, we have an angle measure, so now we're looking for one other piece of information. We're either looking for a side or we're looking for an angle measure. So let's look. What else do we know here? Well, one thing I also know, I have to recognize, is that I have a pair of vertical angles around the middle here. So I just have to be able to name those angles. Now this one we do have to use 3 letters, so I'm going to say angle BCA congruent to, now since I start with B, I got to go over here to D because B matches up with D. So we go D, C, and E. And our answer is going to be vertical angles. All right, so that gives us another angle measure here. So we have, notice here, we've got an angle measure here, a side, and an angle measure here, congruent to angle, side, and an angle measure here. So we can say that our triangles, so triangle ABC, this we're getting this from our what we're trying to prove statement, congruent to triangle EDC, and our reason is going to be by angle, side, angle. All right, let's moving on down here. Let's look at the angle, side triangle congruence. So if 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle, then the 2 triangles are congruent. So in this case here, if angle A is congruent to angle D and angle B congruent to angle E, and then we have a side, so we have BC congruent to EF. So then we have angle and angle side. We know that our 2 triangles are congruent. So triangle ABC congruent to triangle DEF. All right, so now let's look at a proof and use this, okay? So we have our picture over here. We have YZ bisects angle WYX, and we also know that angle YWZ is congruent to angle YXZ. So those are given information here, so we'll mark those in our page after we write them down. So we'll say YZ bisects angle WYX. So that was given, but after we write given, we need to go ahead and mark it on here. So YZ bisects, which means when it bisects an angle, okay, but this means that it's going to cut it in half, which means that tells us that this is going to be congruent to this. So I need to name that angle. Now I can't just say angle Y, so I got to be specific. So I'm going to call it angle WYZ congruent to angle. Since I start with W, and I know that W has to match up with X from our congruency statement, what we're trying to prove. So X, Y, Z. And so the reason for this is going to be definition of angle bisector. I have seen it before where it just says definition of bisector, but definition of angle bisector gives us a little more information here. So this is an angle measure here. Now the next step, we're going to write down what our given statement here. We have angle YWZ, so that we don't want to forget about our last given statement here, which is angle YWZ is congruent to angle YXZ. So YWZ is congruent to YXZ. So this angle here, so that is our second angle. That was given, so we're going to write that down here. Okay, so we're looking for one other reason here, and we know that that YZ is congruent to itself, so we can say YZ congruent to YZ. And because it's not overlap or flip triangles here, then it's going to be just the same order, YZ congruent to YZ, and therefore the reason is reflexive. Okay, so we'll mark that up here. We got this line congruent to itself. That gives us a side. So now we can say that triangle WYZ is congruent to triangle XYZ, and our reason is going to be angle, angle, side. So we have an angle measure here, and side length here to an angle, angle, and side of the other triangle. So they have to be the same in both triangles in order to be congruent. All right, let's take a look at the next one. Number 5. We have triangle or angle ABC congruent to angle CED. So let's go ahead and write that down. Angle ABC congruent to angle CED. That's given. So let's go ahead and mark it. ABC, which is also the same thing as angle B, congruent to CED, which is the same thing as angle E. Okay, now we got those two marked. Next, it tells us that AB is parallel to CE. Okay, also given. So let's put that up here. They're parallel, so AB parallel to CE. So we're going to put a little arrow to show that these are parallel. Okay. Oops. Now we go back to our next statement here. So what do we know because they're parallel? Well, we know a couple things here. We know that, the main thing here that we're going to know is we're going to recognize that because these are parallel, then the line AD acts as a transversal. So therefore, this angle is congruent to this angle. Okay, and that's, so I can say angle A. Okay, so I'll say angle A is congruent, and I can't just say angle C here, so I got to say angle ECD. Okay, and that's going to be because they are what type of angles? They are corresponding angles. So anytime we have these special angle pairs, be looking for, or parallel lines, we be looking for your special angle pairs. So this gives us now an angle measure, another angle measure here, and we're looking for anything else we know to be true here. Well, it also tells us C is the midpoint of AD. So C is the midpoint of AD, which tells us that this part here is congruent to this part here. Of course, this was given, and the part that we know now to be true is we're going to say that AC congruent to CD, and our reason here is going to be by the definition of midpoint. So now that we have this gives us a side length. So it's not the included side, so it's a non-included side. So now we can say that triangle ABC is congruent to triangle CED, and our reason is going to be by angle, angle, and side. So when you're working a problem like this, when you don't have any statements or any reasons, it's okay if these are out of order. You may have wanted to do the midpoint before you did the parallel lines. Okay? You may wanted to write the parallel line and then do the midpoint. Either way is fine, as long as you kind of keep your information straight. And it's your last statement of reason or what you're trying to prove. Okay? All right, so let's look at number 5, or 6 here. So now this one says that PR bisects angle QRS. So PR is going to cut QRS in half. So QRS is this angle here, which means that these two angles are the same. So we're going to write this down. PR bisects angle QRS. Once again, it's given. And so what do we know because of that? Well, we know that angle SRP is congruent to angle QRP. Okay, so it bisects it, so this is going to be the definition of angle bisector. So put an A here for an angle. Now, the next thing it tells us is that angle PSR is congruent to PQR. So we marked it up here. So PSR congruent to PQR. And once again, this is given. And so now that gives another angle measure, which may need a side link somewhere. And because of the way the picture is drawn, we can say that PR is congruent to PR by the reflexive property. Now, because that PR bisected angle QRS, and these two are congruent, so that means that these were not flip-flopped figures in here. Okay, so that's why by the reflexive property it didn't swap places. The letters didn't interchange. All right, so now we have enough to prove our triangle's congruent. So triangle PSR is congruent to triangle PQR, and that is by, once again, angle, angle, side. All right, so let's take a look at our last problem, number 7. This one says LG is parallel to JM, so let's go ahead and mark that here. LG, put a little arrow here, JM, parallel. Okay, so we're going to write that here, LG parallel to JM. Okay, now that's going to tell us a lot of information here, so what do we know from that? Well, let's finish writing this point so we know which angle to choose here. So we got H is the midpoint. Of LM. So once again, this was given here, given here. So let's mark this on here. H is the midpoint of LM. So that means if H is the middle, that means that this half is congruent to this half. So LH is congruent to MH. And that is by definition of a midpoint. So now that we know that this is our side, okay, we can now look at our next angle measure here. And so let's see here. We could actually do this a couple ways and get different reasons here. So you may choose something different than somebody else, but you can still prove it congruent either way. So I'm going to choose to say that angle G, this angle is congruent to this angle over here. Okay, because we know they're parallel. So angle G is congruent to angle J. This would be by alternate interior angles. So It gives us an angle measure here. We had a side length up here. So now we need to have either another angle measure or a side length. In this case right here, I can see that I have a pair of vertical angles. So I just need to name them. So angle LHG is congruent to angle MHJ, and this is by vertical angles. Whoops. Okay, so that gives us this angle here. So if we look at this here, we have angle, angle, and a side. Congruent to angle, angle, and a side. So we have to prove our triangle is congruent. So now we can say that triangle LGH is congruent to triangle MJH. Whoops. And our reason here is going to be angle, angle, side. Now, we could have let angle L be congruent to angle M because of alternate tier angles, which would give us angle, side, angle. Okay, so a couple ways to do it, and there's, like I said, there's more ways than one to prove some of these. Your homework, it will guide you. So they'll give you some statements and they'll ask you some reasons. They may give you some reasons and ask you what statement goes there. All right, so that concludes our lesson on angle, side, angle, and angle, angle, side.